All right, so today we're going to do determining recursive and explicit expressions day 1, and then next time we'll do a day 2. But we're going to start off here, and for this, let's start with the vocabulary of recursive formulas. So write this down as I write it down, and you can pause the video if you need more time. So recursive formula expresses each new term of a sequence based on the preceding term in the sequence. And preceding just means the term that came right before. So the recursive formula expresses every new term of a sequence based on the previous term in the sequence, okay? And so we have one recursive formula for the arithmetic sequences, and we have a recursive formula for the geometric sequences. Let me remind you what happens in our arithmetic sequences. So in arithmetic sequences, this is when you are adding or subtracting every single time. So add, subtract each time. And we're adding or subtracting by the common difference, okay? And we'll get to that later, just to remind you. We also have the geometric sequences, which, let me remind you, is where you multiply every single time. Or multiply each time, however you want to write it. And you multiply every single time by the common ratio. And we will get to that soon as well. Okay, so now let's write out the formula. I want you to write it out like this. A sub n, that's a very little n on the bottom right-hand corner. I don't want to see anybody writing it like that. This is wrong. Do not write it with a big N. It has to be a tiny little n on the bottom right corner. So A sub n is equal to, the sub just means it's on the subscript, which just means the bottom right. So A sub n is equal to A sub n minus 1. The entire n minus 1 has to be small and little on the bottom right-hand corner, okay, plus d. And I'll explain what that means in just a moment. But let's write down our geometric formula as well. We have G sub n is equal to G sub n minus 1 times r, okay? And we'll explain all of this together. So first of all, this A stands for arithmetic, okay? So A stands for arithmetic, and we're having A sub n, which stands for the nth term, okay? And you're like, what does that even mean? Well, if this example on the bottom, that's your first term, then this is your A sub 1 because it's your first term. Then this is your second term, so it's A sub 2. This would be your third term, so that would be A sub 3. This would be your fourth term, that would be A sub 4, because that's an arithmetic sequence. And then for this geometric sequence, or geometric formula, very similar. G stands for geometric, and G sub n is just your nth term. Okay, and so we have your nth term as G sub n. So if you take a look at this geometric sequence that we have over here, then your first term is G sub 1. This is your second term, so G sub 2. Third term, G sub 3. Fourth term, fifth term. Okay, so the G just stands for geometric, the A stands for arithmetic, and the little number on the bottom right represents the term number. Okay, so then we also have A sub n minus 1, that's just your previous term. And same thing for the G sub n minus 1, this stands for previous term. Okay, that's why it's a minus 1, the last one. And then the plus d that happens in the arithmetic sequences, remember arithmetic sequences add or subtract every single time. So you take your previous number and you add or subtract your common difference. This is your common difference. And then similarly, for your geometric term, you're going to multiply every time. What are we multiplying by? Hopefully you remember, it's called your common ratio. So the R stands for common ratio. So if you're not done writing it, you can pause it and you can replay it as many times as you like, but we're going to move on now. So let's go on to number 1 and 2, starting with 1, of course. Okay, so in number 1, we have to determine whether each sequence is arithmetic or geometric, then use the appropriate recursive formula to determine the unknown terms in the sequence. So let's see if it is arithmetic. If it is arithmetic, we will be able to subtract 2 consecutive numbers and get the common difference every single time. So I'm going to try that out. Let's choose any 2 consecutive numbers. I choose those 2. And let's see what we would get as our common difference. The second number minus the first number. Okay, so that's the second number minus the first number. That simplifies to -9 plus 2, which would be -7. All right, let's see if this common difference is actually common and happens again when we pick another 2 numbers. So if I chose those 2 numbers, let's try it out. We have -23 minus -16, second number minus first number. So it's -23 plus 16. So then if you calculate that, that gives you a D, a common difference of -7. Then you can see that we got -7 both times, which means that indeed this is arithmetic. So I'm going to put this in a box. Okay, so we have an arithmetic sequence here. And so if we have an arithmetic sequence, we will be using the arithmetic recursive formula. So let me write it out. A sub n is equal to a sub n minus 1 plus d. So that is our formula. Okay, and so let's see, which term are we even trying to find? This is the first term, the second, third, fourth, fifth. We are looking for the 5th term. So a sub 5 is equal to a sub 5 minus 1, meaning our n value is 5. So where we had an n, I now have a 5, okay? So our n value is 5. Now we're plugging it in. And then plus d. Okay, so a sub 5, which is what we're looking for, is equal to a sub 5 minus 1 is 4. See how it's the 4th term? And then plus the common difference. Plug everything in now. Our a sub 4, which is our 4th term, aka our previous term, which is this one. So it's -23. And then plus the common difference, which is -7. So when I add the -7, I'm really subtracting 7, so I wrote it down like that, just -7. So then we get a sub 5 is equal to -23 minus 7, which is -30. And so therefore our answer here is -30. Okay, and so at this point you guys can pause it and try out number 2. See if you can get it. If you don't, that's totally fine. Make sure you guys ask me any questions if you have any. All right, so now we are unpaused, and let's take a look to see if you got number 2 correct. So let's try to see if this is arithmetic or geometric. I'm going to start by picking 2 consecutive numbers, 4 and 12, and let's subtract them. Second number minus the first number. If I do that, I get that the difference here is 8. Let's see if the same thing happens when I choose another set of consecutive numbers, 12 and 36. So when I choose 12 and 36, you do the second number minus the first number, and then I get that the difference here is 24, which shows me that since we got an 8 and then we got a 24, this is not arithmetic. So I'm going to cross that out. And let's try to see if it is geometric. So geometric, we're going to take those same pairs of numbers and divide them to find our common ratio. So you do second number divided by the first number, and I get 4. Okay, so maybe the ratio is 4. Let's try it again over here. Oh, sorry, it's not 4. Silly me, it's a 3. Hopefully you were watching it and you were like, That's a mistake, Miss Jade, but it's okay, we all make mistakes. It's because I wrote 12 divided by 3 for some reason, when it's really 12 divided by 4, because our first number is 4 here. So 12 divided by 4 is 3, and so here we have a ratio of 3. Now taking a look at the second pair of numbers, 12 and 36, we get 36 divided by 12, which gives us 3 as well. So then our ratio is 3, and then our ratio again is 3, which means our common ratio is 3, which means we have a geometric sequence. So now that we know it's geometric, we have to write out our geometric formula. Okay, and then let's plug it in to solve for our, let's see, 1, 2, 3, 4th term, and 6th term. Okay, so we have a 4th term, so g sub 4 is equal to g sub 3 times r. And then later on we'll have g sub 6 is equal to g sub 5 times r. I'm just writing it out now. So let's see, for our first one, we have g sub 4 is equal to g sub 3 times r. The previous term was 36. Let's plug it in. Can't plug it out, Miss Jade. Silly. Okay, 36 times the common ratio, which is 3. And then so we have 36 times 3. If you did it on a calculator, you get 108. Or you can do it in your head and get 108. It's up to you. So then our 4th term is 108. So I'm putting that in our blank space there. Okay. And then we also want to find our g sub 6, our 6th geometric term. So that is equal to the 5th term times the common ratio. So let's see, plugging it in. Oops. I like to be consistent with my colors. So let's do that. G sub 6 is equal to 324 times our common ratio, which is 3. Let me just circle those. Okay, how do we know it's a common ratio? 3 right there. So we have 324 times 3, and we get 972. So you can fill it in the blank space over there. All right, so that's how you do these problems. We're just using a formula. You don't have to show all the work like I did over here, but you gotta show the steps that I showed over here. So pretty much, let me get you stars by the steps you need to show. This step, and the answer. Okay, that's why here we just have pretty much this step, and the answer. Okay, so that's all the work you guys need to show. If you have any questions, please let me know, and I'll be sure to help you out after that. So call me over if you have any questions.